Hello, welcome everyone. Today we will be having an amazing session where we explore the cutting edge world of aerospace innovation and entrepreneurship. I'm your host, Abdullah Larash, the co-founder and COO of SpaceTech in Gulf. Basically, we are an analytical and marketing and consulting company in the space industry within the MENA region. And now we're actually glad to have with us Marwan and Saif. They are the founders of Advanced Rocket Technologies, the first private launch provider in Africa and the Middle East, with their upcoming Horus 4 rocket launch from Oman Itlaq Spaceport. So Advanced Rocket Technologies is paving their way for affordable access to space for scientific and educational communities. So ladies and gentlemen, join us today as we dive into their mission, the challenges they have faced, and their vision for future of space exploration. Thank you, Marwan and Saif, for being with us today. I hope you're doing great.
Thank you, Abdullah, thank you for this opportunity. And I'd like to thank SpaceTech and Gulf for providing and enabling us to discuss more about our upcoming launch from Oman. We are really excited about it, to share more insights with you guys and to make our first launch from the Middle East, which is our goal. So, yeah.
That's amazing. Actually, I believe everyone here is excited for this talk, and I am actually pretty excited for it. So to kick things off, let's talk about your upcoming Horus 4 rocket launch. So what are the key objectives of this mission, and can you share specifics about the flight numbers, such as the altitude, speed, thrust, or any other technical details that you would love to share?
Yeah, of course. First of all, thanks, Abdullah, for the introduction. It's an absolute pleasure being here and having SpaceTech and Golf hosting us right now. Just to quickly introduce myself, I'm Saif Zaharan, CEO and founder of Advanced Rocket Technologies, and we also have Marwan. He's the Chief Operating Officer and co-founder with me. So, talking about the Unity 1 mission, so it's actually the inaugural launch of Advanced Rocket Technologies. It's a major actually milestone for us. We've learned a lot just in the past 2 years alone. We've registered 2 years and we've gathered a team, and within 2 years to make a prototype, I think we have made an incredible achievement. So one of the key objectives for the Unity 1 mission is advancing reusability. So reusability is actually very, very important if you want to, offer cheaper access to space, to customers. And it's really key that, you have to perfect the reusability. And that's why we literally, in terms of reusability, we literally like taking the challenge head on. And the next thing of the objective is operational experience. So literally over the past, 4 months, we've been working with Itlaq Spaceport, and they have been incredibly supportive, and the knowledge we've gained from them is priceless in terms of the logistics, regulations, prepping up for the launch, the days leading up to the launch, and we still haven't even got there yet. So I'm sure there's still plenty of much more to learn, much more experience for the art team to gain over the next month or so. And it's also a regional demonstration. So the Unity test, yes, it's also a technical test, but it's also, it's a showcase for our mission for the region, to spark interest and attract potential investor in this growing sector. And also in this mission, it's also a remarkable event for the fan zone experience in Duqm. As Itlaq, they'll be launching the first fan zone experience in the region along our mission. And, it's the first public mission, in Oman, and it's an absolute pleasure, having, Advanced Rocket Technologies being the first, of course, as everyone is going to watch. And it's a game. It's a game changer, and it's really proof that the industry is growing. And we're really proud to help lead that launch. And in regarding to the vehicle, we are aiming for an altitude of about 75 meters, and it should reach a maximum launch speed of around 24 meters per second. And we're aiming of a landing speed of 2.5 meters per second, and we have a total thrust of 155 newtons. So yeah, these are the flight specifications that we're targeting.
Thank you. That's actually really, really impressive. And I mean, during Intelaq launch events,
Mm.
your rocket was notably smaller than the others, and your mission seemed to be less newsworthy compared to the large launches.
Yes.
So, can you elaborate on why you made those choices and how they actually align to your long-term growth strategy?
Yeah, of course. So, you're absolutely right. Our rocket is the smallest, in the 2025 launch up. And it might not be the spectacle of larger launches, but that's by design. It's an industry dominated, by giants. However, we're taking a completely different approach. Everyone here knows how risky the launch business is. It's
Mhm.
risky for the investor, it's risky for me, it's risky for the team, and it's really, really risky trying to do this right. And hence why we're taking a completely different approach. So one of the main reasons why we have, chosen, a small rocket is de-risking the business. We would like to start off by de-risking the business as much as we can in pretty much all aspects. So financially, technically, and the some of the launch industry still relies on 1960s era systems, because let's be honest, innovation in this industry is expensive, and I'm going to say it again, it's risky as well. So our goal is to basically flip that model a little bit. We want to test, reusability, propulsion, recovery on a smaller low cost rockets like Horus 4. And we're perfecting that technology before scaling up, saving millions and avoiding catastrophic failures. So that's one of the things. So the second thing is reusability first. As I said,
Mhm.
reusability is really, really critical, in this industry, but it's incredibly hard to master. So if we're jumping straight into, $2 million rockets or $1 million rockets straight away testing, the reusability systems, it's not going to be as efficient. And hence why, we've made that decision to start small and build up literally along the way. And we will eventually, build larger systems. And, small rockets lets us iterate, fast and cheap. And we'll have thousands of test hours under our belt and dramatically improving success rates, and driving down price per kilogram eventually. So, we are playing the long game, while some others, choose headlines. We want to really build a really strong foundation for a sustainable, affordable space flight today.
Exactly, like emphasizing on safe words. Like,
Mhm.
keep in mind that Unity One is our cornerstone mission till we reach space, the outer space, and putting something into orbit and getting there, and also being the first space rocket project for the Middle East, which aiming to not just launch but build the rockets in the Middle East and reuse them, kicking the project with multi-million vehicles and risking, يعني having the risk of losing them on the launch pad or above it. Like, it's gonna like drain, the ambitious of reaching the space, but starting small, learning through the way and improving our systems. Inshallah, definitely we will be there like in a very short time.
I mean, that's a really smart approach to start, from smaller rockets to bigger rockets. And I hope that you reach actually to multi-million launches rockets, and I believe
Inshallah.
it's doable.
Inshallah.
So let's dive into the technical side now.
Okay.
So can you elaborate on the propulsion system? Like, are you using solid or liquid fuels?
Mhm.
And what's the expected, let's say, combustion chamber pressure and temperature? And most importantly, like, why you target lower altitudes and shorter flight duration?
Of course. Yeah. So, going back, to my previous point, the we've opted in for solid fuel propulsion for Unity
Mhm.
One, so because we are prioritizing cost efficiency and operational simplicity at the stage. We want to minimize complexity, reduce development
Mhm.
cost, and really focus on that reusability. Liquid engines do offer high performance. We can throttle them. They're much more powerful. It gives us much, much more, let's say, playing ground, for us to test, these systems. But at the same time, it's really expensive, building a not okay, I'm not going to say building, but developing a liquid system from scratch. You know, incredibly time consuming, and you know, we really want to focus on the main thing that will offer the customers a cheaper access to space. That's the main thing that we are focusing on. And the control system pretty much is so we use electrical and mechanical actuators to gimbal the nozzle. So we have a thrust vector control system. Most of our avionics are commercial off-the-shelf IMUs and flight computers, and they are tuned for rapid response during ascent and landing. And for landing, we have grid fins, and we also have algorithms adapted, you know, from other systems as well in order to achieve a soft landing. And answering to your question, why 70 meters? So 70 meters provides us approximately of about 15 seconds of flight time. That is enough to validate thrust vector control responsiveness, stability during powered descent, landing leg deployment, and impact tolerance. If we decide, for example, to go, you know, for a higher altitude or longer thrust time, we've done the trade-off analysis, and it turns out, you know, if we decide to go higher, then we would have to, you know, it's a little bit more risk, you know, because more distance will be covered, because at the same time we have to be safe. You know, the Unity 1 mission, advanced rocket technologies want to prove that we can successfully and safely operate a launch vehicle, you know, within the environment. So that's as well one of the main thing. So then, you know, even at 70 meters, so at this altitude, so any anomalies, you know, is not going to put is minimal risk, you know, to any infrastructure or personnel as well. And, you know, again, iterative scaling, you know, for future missions, we're going to extend the altitude and the duration, you know, as we validate our systems. So, you know, again, with the long game, pretty much.
Yep. Also, like the systems we have built for Horus for like in Unity 1 launch can easily get us to 1,000 meters, by the way, but we are still targeting a lower altitude because the safety like configurations that Safe mentioned that we need to keep in mind. And also it's our first launch. Plus, we're not here to make a show about our launch. We can easily launch it to bigger altitudes. It's not a problem, but we are here to learn, you know, get the experience, get the data, improve our systems, and get there safely with the lowest risk possible.
That's amazing. I said play it safe. And speaking of safety, let's talk about the safety protocols now. So as we know, that safety is the highest priority in any aerospace activities. So can you tell me, like, how does your team actually ensure that the vehicle and the subsystem operate within the safe parameter during the flight and recovery as well?
Of course, yeah. So I can give a little bit more detail on that. So again, so we've been working very, very closely with the regulators. We've been working very, very closely, you know, with the National Space of the CAA in Oman and the Itlaq Spaceport team, you know, and they ensured that our flight profile, launch procedures, contingency plans, they all have to meet safety requirements. So that's one of the things that we've done. Also, you know, there's a dedicated safety zone, you know, where, you know, with Itlaq as well, we have to guarantee a minimal risk to personnel and facilities, you know, in the unlikely event of an anomaly, and the vehicle remains within a pre-approved hazard area as well. And talking about, you know, the vehicle itself, so, you know, we do have redundant flight systems, you know, to tolerate single point failures. We also have real-time telemetry, you know, to monitor the IMU readings, the GPS readings, the servo readings, and we also have so, you know, designed the rocket in order with, you know, higher grade alloys, an example for the landing legs. You know, stuff like that, you know, we have to make sure, you know, that in case something goes wrong, we've basically planned out everything from A to Z.
That's really nice, and I hope everything goes as planned and you have an amazing launch. So talking about the strategic roadmap now. Unity 1 mission seems to be a stepping stone for advanced rocket technologies. So how does this fit into your broader strategic roadmap for scaling launch capabilities?
Of course, yeah. So when advanced rocket technologies was first registered, or let's say started really. So we came up with an initial three-phase plan. So this three-phase plan starts with Horus 4, which our current rocket at the moment. Phase 2 is we will progress to suborbital systems, and phase 3, it will be an orbital system. And very, very specific milestones have to be achieved in order for us to move on to phase 2. And again, in terms of reusability, and in terms of how the rocket is engineered in Oman, and all that stuff pretty much. And again, reusability is not just about hardware pretty much, and the same. One of the things that we're trying to do is operational repeatability. So some companies spent millions of dollars trying to do this, but one of the reasons why we've came up with the three-phase strategy is for operational repeatability, and also de-risking the plan. Again, it fits perfectly within our starting small and incrementally building bigger vehicles.
Yep. Also, we are adding, we are using reusability, as we said, across all the way, which is it's an important techniques to get the rockets cheaper, because if we are gonna build rockets like everyone the same way they have been doing it, then we are not gonna add anything to the industry. We're not gonna make them accessible, and we will just be another company making rockets expensive for everyone. So targeting it on a small scale, and trying to make it our cornerstone, using Horus as a learning step to make them reusable. Across the three phases. Once we get done with Horus 4, phase 1, we're going to move to reusable suborbital rockets. Phase 3, reusable orbital rockets, and so on.
That's really amazing. I mean, the design challenges, looking at them, rocket development is not an easy thing to do, of course. So what are the biggest, let's say, design and testing challenges you have faced during the development of Unity 1? And how did you overcome them?
Well, so one of the things that we have really struggled with is let's say, well, starting off, Unity 1 was on a budget, with limited local production, and it really forced us, to innovate in ways. So one of the biggest hurdles that we face is the Goldilocks weight problem, pretty much. So it's essentially solid motors available in the UK. They have fixed thrust profiles, but we do know how much thrust they produce over a certain period of time. So we really had to hit that sweet spot, in order for, putting all of those reusability systems in the vehicle, having all the sensors, the computer, all of those components, and having the weight and the stability of the rocket hitting that sweet spot to enable a soft landing at 2.5 meters per second was quite hard. We had to change the design of the internal components like close to about 50 times, I'd say. But yeah, but yeah, we've overcome it. The vehicle is designed in an absolutely phenomenal way. Everyone in my team, Saif, Muhammad, Khalid, Marwan, everyone in the team, they've been working extremely hard over the past few weeks, to get this done. And yeah, it's been an adventure, I have to say.
And hopefully all of this, hard work will pay off very soon.
Inshallah.
So let's say after Unity 1 concludes its mission with success, inshallah,
Yeah.
What's are the Advanced Rocket Technologies' immediate next steps in terms of project development?
So, Advanced Rocket Technologies right now is based in the UK, but we would like to be based in the Middle East and Oman. So our immediate next step is to be back to the launch pad as quickly as possible with a higher altitude and bigger goals. To keep a good progressive path of continuous technical development, and we will also start our seed funding campaign after the launch, not to only bring, only rocket launch operation to the regions, but also manufacturing them, around with, support of local and international partners, as well. So immediately we want to get to, we want to be back on the launch pad, and yeah, we would like to, officially make that move, from the UK and start operating and building rockets from Oman.
That's really amazing. So looking ahead, like what are your plans for scaling operation and enhancing project capabilities following Unity 1?
So, our long-term vision. So initially it's crawl, walk, run approach. It's perfect recovery technology before, scaling propulsion. And we want to avoid those early pitfalls. We want to really, yeah, 100%, because any pretty much pitfall right now, well, I'd say to any space company, it will be, explosion of costs, pretty much, and then it's going to lead up, and that's usually not a good sign of a space company, pretty much. And we also want to build investor confidence, with small incremental wins. So with the scale of operation, within the next, let's say, 3 or 4 years, we would like to set up the first commercial service in the Middle East. And enhancing the project capabilities, that's when we keep iterating our rockets. After Horus 1 there will be Horus 4.1, going higher, going quicker, and then eventually we get to suborbital, and then inshallah orbital. That's our big goal.
So finally, let's talk about the people behind Horus 4. Like how many
Yeah.
individuals contributed to its development, and what are your primary source of funding for this ambitious project?
Yeah, of course. So honestly, like, we have an incredible team and engineers and advisors, who've been with us, since day one, really. They're sharing the same vision, the same goal, to build and launch rockets from this region. We have about 10 engineers working on Horus right now, on structure, guidance and navigation, ground station. And pretty much our project is self-funded again, since day one. And we got some help from friends and family so far, as they also believe in our dream of reaching the space, pretty much.
That's really amazing. So fortunately, we reached to the end of our questions. So as we wrap up this fascinating conversation with Advanced Rocket Technologies, it's clear that their innovative approach, actually, not to space exploration, is not only advancing the regional capabilities, but also redefining the affordability in rocket launches as well. The upcoming Horus 4 mission is just the beginning of their journey toward access to space for scientific communities worldwide. So thank you for being with us, and thank you for sharing their insights, and thanks for our listeners and everyone who attended this quick webinar. I hope you enjoyed it and hope to see you very soon. Thank you all.
Thank you, Abdullah.
Thank you for everyone who joined us, and we would like to welcome you soon to witness our launch from Itlaq Spaceport, whether in person in the fan zone. Join us in the fan zone or online. We will have live broadcasting for the launch. That would be great to have you all with us. So thank you for today, and see you soon.